Hi, this is Kevin. Welcome to my Beyond the Textbook lecture for Chapter 7 of the Zelle 3rd edition Python book. And Chapter 7 is about decision structures. And there are some things that were covered in the book that I have in this supplemental project. Okay, so this is a supplemental project for this lecture. You should be able to download this from the weekly schedule. Okay, and I do have a program for the simple if. Okay, and in this case, we are getting we're doing in this series of programs what people tend to do when they're demonstrating this conditional execution. They talk about the weather. Okay. So we prompt the user for a float, which we want the temperature in Fahrenheit. And if it's less than or equal to 32, we say, "Brr, it is freezing today." And in any case, after the if, we print "Thanks for playing." And you won't be too surprised to know that if I run this and say that it's 45, well, it's only going to say "Thanks for playing." And if I run this and say that it's say 32, it's going to say, "Brr, it's freezing today, thanks for playing." And I guess the only extra point that I have to make here is that for beginners, a common problem is they get statements either included in the code block that's hanging off of the if when they don't want to. So they get too many statements included in the code block, or too few, right? That's why we have this final print. And the other thing is it's pretty good for program design, and it's a pretty good choice to always show some output, right? So the "Thanks for playing" takes care of that as well. All right. So that's all I have to say about the simple if. We really talked about it in the chapter itself. The next thing here is chaining comparison operators. And there was an example of that in the chapter, but I just want to emphasize this bit as well. So in proper circumstances, chaining multiple comparison operators in the same kind of test expression can lead to more readable code. And again, the example that we want to look at is this O2 chaining comparison operators. So let's take a look at that. Okay, so let's see what we've got. We have, we're going to compare three things, okay? And we're just going to, we're going to ask the user to input three integers, first, second, and third, okay? And then we're going to analyze those. The first time that we analyze them, we're going to use the syntax that doesn't use this chain comparison operator syntax. And then the second time we are. Okay? So let's look at how it runs. Okay? So we're going to give it a run. So Here's what we want to do. Let's give it 3 that are in the proper, in this case, the proper order is ascending order. So let's just say 10, 20, and 30. And then we're going to test it twice, and both of the tests are saying that the values are in order. And that's using the syntax that's not, without the chain comparison and then with the chained comparison. So if we don't use this chain comparison syntax, then we can only compare 2 things at a time. And so if we want to do 3, we need to have 2 two-sided comparisons joined by an and. And it's not too confusing, right? But you can imagine if we wanted to check if 4 things or 5 things or 6 things were in order, that'd be a whole lot of ands, right? And you can even see here that the PyCharm code analyzer is suggesting, if we come over here and we hover over this, it says it wants to simplify into a chained comparison. So this is a significant enough coding improvement that they've trained PyCharm to recognize it and recommend that we change the, hang on, excuse me, that we change the way that we express this. And if in fact we were to, to click on the action link and tell it to recode it, it would have created this second version, okay? And it's possible to not just have 2 sides to a comparison. We could say first less than, second less than, third, and all that is tested together. So you can abuse this, okay? But generally speaking, people consider this chain version to be easier to read and probably easier to code than the unchained version that's up here on line 12. Okay, so that's what we recommend that you do. And the good thing is, if you're using PyCharm Professional, it's going to give you a hint and it gives you a link that actually will change the code. Pretty nice stuff. So that's the chain comparison operators I wanted to talk about. Another thing that's talked about in the text, but I want to emphasize it here again, is that when we're testing variables for what their contents are, there is a way to test variables for this thing that we call truthiness, regardless of their type. Okay, so if we test a variable and we just say if variable name, okay, depending upon the type, empty and 0 values evaluate to false, and non-empty and non-zero values evaluate to true. Now, some programmers, not all, but some, believe that this leads to more readable code. Okay, and you can decide for yourself. I teach this here for 2 reasons. One is that this coding style might appeal to you. And the other is if you're maintaining other people's code, which is going to happen if you're using open source code or you're finding code examples in textbooks or on Stack Overflow, well then you'll know how to read code that uses this truthiness trick. And I have a link here to a tutorial article. Let me just pull that over and show you. This is one in Geeks for Geeks that kind of goes through more details of how to do these kinds of tests. Okay. So, what does this look like in code? Well, we're just going to go to O3 truth value testing and take a look. Okay, so let's go to O3. Okay, and so here's what we have. Uh, uh, what we're trying to do in this program is to test if a list is empty. Okay, so we're going to ask the user, should this list be empty, Y or N? Okay, and on the basis of the response that we get, we're either going to create an empty list called the list, or a populated one that has the strings "my dog has fleas." Okay, and then we're going to test it two different ways. One, okay, uh, the kind of explicit Python syntax way, the one that doesn't use the kind of truthiness syntax shortcut. And then we're going to do it using the truthy syntax shortcut. So first, let's demonstrate that these give the same answers, right? So we're going to give this a run. Okay, going to pull up the thing here. So determine if a list is empty. Should this list be empty, Y or N? Okay, Y. Okay, and then let's see, we tested it both ways without using truth value testing. So another name for truthiness, and maybe the more official name of this feature in Python, is truth value testing. Truthiness is very popular with some textbooks will use this, some tutorial articles will use that, right? But the official name, I think, is truth value testing. So without using truth value testing, it's empty. Using truth value testing, it's empty. Okay, so it works the same way. And then let's do it the other way. Determine if the list is empty. Should this list be empty? N for no. And then we say the list is not empty. The list is not empty. So clearly these tests work the same way. Okay, and the explicit and literal way to test this is you just check if the length of the list is not equal to 0. If the length is not equal to 0, then it's not empty. Else, it's empty. Okay, but if we want to use this truth value testing syntax, we can just say if and use the name of the variable, if the list, print the list is not empty, because if it's not empty, it's true. Okay, so lists, when they're empty, are false, and when they have contents, they're true. Okay, so if the list, then we say the list is not empty, else the list is empty. Okay, so there we are. All right, so truth value testing, it's not a syntax feature that you have to use, but it's one that you should know. Moving on. Okay, so let's just do a review of the two-way if. I think this is pretty well covered in the textbook, but it's worth a look because we'll get a consistent set of examples here. So that's O5 two-way. Okay, and again, this whole series was all built one on top of the other. So we're prompting the user for the temp in Fahrenheit and expecting a float, okay? And if the temp is less than or equal to 32, we're going to say, we're going to print Burr, it's freezing today. Else, we're going to print, well, at least it's above freezing today. And in any case, we're going to say thanks for playing. And I want to point out that this, line 10, is not part of the code block for else, even though it doesn't have a blank line in front of it. And again, for beginners, one typical things, and it happens on, if else, it happens in loops. Whenever we indent a code block and then we have code that follows it, a common error is that we get too many statements in the code block or too few, and then we start getting silly output. So if we're to run this, okay, so if we're going to do boundary value testing, it looks like the boundary value is right between 32 and 33. So first, let's say 32. Burr, it's freezing today. Thanks for playing. And then if we run it again, and we're just the other side of the boundary, 33, well, at least it's above freezing today. Thanks for playing. Well, very good. Okay, not too surprising because I think that was covered pretty well in the chapter. And we're going to view the multi-way if, okay, that's if, elif, else, okay. And one point that I really want to make here that I don't think is adequately made in the text is when we're constructing a multi-way if that uses inequalities, and that's what we're doing here, that's the more challenging way to do it. You must test conditions in some kind of order, and ascending order is preferred. So let's go look at 10 multi-way. All right, I'm going to close all these that are clogging up our workspace and open up 10. So here we're going to test for ranges of temperature using inequalities. And this is a typical thing that we do when we're trying to categorize things. Okay. Okay. And these only work when they're done in order. Okay. Because, well, we prompt the user and we say if the temp is less than 0, less than or equal to 0, we say, watch out, it's Chicago cold today. So I live in the Chicago area, and most people in the Chicago area think it gets especially cold here. Okay, so that's why I say that. And then we say elif, temp less than or equal to 32, print Burr, it's freezing today. And then the else is, well, at least it's above freezing today. And what we're doing is that we're categorizing the data, okay? So we're going to catch everything 0 and under and put it into the Chicago cold category. We're going to take 32 and under, but not 0 or under. We're going to catch the next band of values and do the freezing today, and then we're going to catch the band that's left over. This only works if these are in a proper order, and the order that I recommend is ascending order. Okay, could you do them in descending order? You could, okay, and some people do. But I think they're easier to understand where they're in ascending order. Probably exceptions to that. But they should be in some kind of order, and you should have a consistent style. Okay, so let's give this a test. Okay, so let's work at the boundaries. So we want to know that 0.0 is going to get us Chicago cold. So let's do that. Let's say 0.0 Chicago cold. That's good. And let's run it again. And we want to know that 32.0, that's just 32, is going to get us freezing. And then we want to know that above freezing, which would be, let's say 32.1, right? 32.001. That should do it. At least it's above freezing today. So very good. All right, so put these in some order. I suggest ascending order. All right. Okay. So something that's not really not really shown explicitly in the chapter is these multi-way ifs can get long. Okay, and I call this, not everybody does, but I call this an extended multi-way if. It's like a multi-way if, it's just long. Okay, and again, if it uses inequalities, and a lot of these do because we're using them, we can use this structure. One common use, and we'll explore it in a minute, is to do a lookup of exact values. Okay, but another one, a very common one, is to categorize values based upon bands of values, right? And again, they only work if they're in a particular order. I recommend the ascending order. So I demonstrate this in 15 multi-way extended. So let's go open that program. Okay, and this is just more of the same. And I'll say this. Let me close that box there. The longer these things get, the easier it is to make a mistake, right? So having a system for how you're going to set them up helps. Now, if you look at what I've done here, all the tests are the same test except the last one. So everyone is less than or equal except for the last one. Why did I not make that less than or equal? I don't know. Maybe to show that I could, right? So having a parallelism helps a lot. Okay, when you're trying to classify things, doing them in some kind of order, preferably ascending order, is going to get the job done. So here, if it's less than or equal to negative 50 Fahrenheit, it's Arctic cold. If it's less than or equal to minus 20, it's Minnesota cold. Even though the people in Chicago think that the weather in Chicago is cold, the people in Minnesota know that it's a lot colder there. If it's less than or equal to 0, it's Chicago cold. Less than or equal to 32, it's freezing today. Less than 40, wow, see, I just want to less than 40. So less than 40, at least it's above freezing. Less than or equal to 70, we can expect to see the undergraduates wearing sandals today. And then less than 80, what a beautiful day. And I want to emphasize, only one of these things is going to be true. As soon as we get a match, we do the activity, we execute the associated code block. Here, each code block is a single statement, and then we leave. So these subsequent tests are never run. So there's an art to doing this. So for instance, um, if it's higher than 32, okay, but less than 40, we're saying that it's above freezing. Okay. If it's between 40 and 70, then we're saying we can expect to see the undergraduates wearing sandals today, which they seem to do every spring. Okay, so that one nice thing about the structure is as soon as you get a match, you don't test the rest of this stuff. Okay. Now, and then you have to pay attention to any code that comes after, uh, making sure if it's not supposed to be in the code block uh, for the decision structure itself, that you don't accidentally include it or exclude code from the code block. Okay, and let's just run this, and let's say that it's 41 today. And we say we expect to see undergraduates wearing sandals today. There we go. All right. Um, what else can we talk about? Well, uh, another use of this multi-way is for lookups. Okay, and the difference between the code that we've seen on the last couple of uh, demonstrations and a lookup is when we're doing a lookup, we're typically looking for exact matches. Okay, so we can code these inline in our code using a multi-way if. Usually, if we're testing for a lot of values, that leads to really long code. So one of the things I'm going to show you here is how much more readable the code is if you take that multi-way if that does lookup and you refactor it into a function. Okay. Now, there are other ways to do lookups, and in particular, when our class gets to um, chapter 11 of the Zelle book, which won't be too many weeks away, we'll be learning how to do a lookup using a dictionary. But we don't want to do that now because we want you to have experience with both. So for now, we want you to use the multi-way if. All right. So we've got two demonstration of programs we're going to look up. We're going to take a look at 20 lookup and 25 lookup in function. So let's go see those. So 20 lookup. Okay, so you'll have to imagine that the code that we see here is in just a part of a larger program, right? So here we have a coding scheme for the data where we're coding the region name. Say our company has sales regions, and they're northeast, southeast, northwest, southwest. There are four of them. And so when we code the data, we code, the region code as an integer, 1 for northeast, 2 for southeast, 3 for northwest, 4 for southwest. Okay, if we want to expand those, right? If we want to go from the code to the descriptive value, one way to do it is to do it with lookup with a multi-way if. Okay, so here we're going to prompt the user, please enter the region code, and we even give them a hint. We're looking for 1, 2, 3, or 4. Okay, and here's what we're going to do. We're going to we're going to test for exactly one, in which case we're going to assign northeast to region name. We're going to test for exactly two. If that's the value, we're going to assign southeast, and then we keep going if it's for southwest. And it's typically good, even if you're not expecting invalid data, to always provide for it. Okay, because you can hear arguments from people like data will never get into our system if it's invalid because we check it on the way in. Well, that's true, but what often happens is that requirements will change, right? And we'll come up with another sales region. Okay, maybe it's called central. Okay, it's the middle of the country, and it's going to be region 5, and somebody forgot to come back and change this program. So when it runs, okay, um, we don't want we, that's going to represent a failure, okay, because we're not really going to detect that. So we don't want silent failures, okay? Not because we expect the data in our system to be low quality, but because changes happen to systems and people forget to change some of the programs. Okay, so the programs should be written, the phrase I use is defensive programming. Okay, so then we're going to set everything else to invalid region, and then we're going to print region code, and then repeat the region code is region name. Okay, so let's look at this. We're going to run this. So if we do a 1, it says it's northeast. If we do a 2, no, let's not do 2, let's do 4, southwest. Okay. What if we do 0? Well, we're expecting to get invalid region. Yeah, we did. And what if we do 5? Same thing. Okay. So this you will thank yourself for this. The other thing that we've done here is we have, I guess it would be possible to put this print hanging off of every elif instead of setting region name. And the problem I have there is that the way that we're going to print it is going to be now in 5 different places instead of just one. So I believe that this is better coding to set the same variable in each of these and then to use the variable at the end. Okay. All right, so that's what we've got there. Now, this is great code. The problem is if this is in the middle of something that we're trying to do, our code's going to get awfully long, and this kind of clutters it up. So a very common thing to do is to take this kind of lookup code and factor it into a function. And that's what we're showing you at this 25 lookup in function. Okay, so up in main, okay, we're prompting the user the same way. Okay, but then what we've done is we've taken all the lookup and we've put it into a function called lookup region name, and we pass it the region code, and the return value is the region name. Okay, so I've divided this code by 2 blank lines so you can see the parts more distinctively, but in a real program you would write on your day job, you probably wouldn't have divided them. So now, how does this code look like when we refactor it into a function? Well, the code looks pretty much the same, except that instead of printing the region name, we're returning the region name. It's also a little more useful in the following way. We can use this in a lot of contexts. Like if we were using this in a program where we're going to put the output on the console, well, then we could do a print and put the output on the console. If we were building the text of a web page that we're going to send back to the browser, okay, we probably wouldn't be using a print in quite the same way, but we could use this function. So refactoring these lookups into functions turns out to be a good coding practice, and it leaves your higher level code infinitely more readable and maintainable. Okay, so what else are we going to talk about here? Okay, so nested ifs, I think they're talked about a little bit in the book, but I want to explore them more. Okay, so nested ifs are ifs that are coded into the code block of another if. Okay, and we're typically doing this to implement a complex choice. You know, typically we've got some kind of policy. It might be a pricing policy or a grading policy or something like that. And it's not only dependent upon a single variable. It's dependent upon several. Okay. So any code block, even the code blocks that are hanging off of an if or an else, can contain another if, a simple if, a two-way if, a multi-way if. Okay, so and when they're inside, when they're in the contained code block, we say that they're nested there. It's a nested if. So nesting ifs to two levels is the most common use of this practice. Nesting ifs 3 levels deep is recommending only if it results in readable code. Sometimes it's still pretty readable. Other times it's not. Most practitioners agree that nesting ifs more than 3 levels deep is going to be a bad practice because the code is not going to be readable. All right. So let's look at two code demonstration programs here. We have 30 nested inline, and then we're going to take a look at the benefits that you might get by taking that code and factoring it into its own function, which I particularly like. So we're going to look at 30 and 35 here. Okay, so let me close these tabs that are open, and let's look at 30. Okay. Okay, so this is a classic example. Okay, and there years ago, I used to work for a property and casualty insurance company that sold auto insurance. Okay. And so I kind of knew a bit about how they did their premium calculations. And I've been teaching these kind of introductory programming courses for a long time, and quite a few people use an example like this to introduce the nested if. Okay, so that's how we got here. All right. Now, one of the things that's interesting about this example is um, it's actually aged because of changes in the world. Okay, because back when I used to work for the property and casualty insurance company, and back when I began to teach these kind of programming courses, uh, many of us who are typical really were not in touch with uh, issues of gender identity, right? And so, you know, people in insurance and people in programming teaching uh, kind of thought that the question of gender was, well, people are either male or female. Well, certainly at the iSchool, we have a much more nuanced idea of gender identity than that. And we know that, oh, geez, I had a client one time who dealt with this stuff in his social services agency, and he said that instead of two categories in his social services agency, they had, I think, five or six or seven, right? But one of the things that I want to point out is that on a really simple level, we could have male, female, and maybe non-binary, right? So um, uh, here's what we're going to do. The high level if structure is a multi-way. Okay. And I'm sorry. The historically insurance car insurance premiums have depended upon the age of the driver and their gender. And this has to do with the fact that males historically have been horrible drivers and have had a lot of accidents, and they should have to pay their fair share of the cost of fixing cars and and people, right? Um, so it kind of makes rough sense until you start to apply a more nuanced gender identity framework to it. Okay, so here we've done on the high level, we have a multi-way, okay, and let's say that this insurance company is not woke yet, okay, but we on the programming staff, we're more woke, okay. I'm probably pretty low on the woke scale, but a little bit, right? So here the first group that we pick off is male, and then we say LF gender equal female, and then we have an else in which uh, we raise an exception, and we haven't gotten to that one yet. So we're going to raise an exception down in number 45, so we'll be there soon. And then what we do is that we blow the program up, and the message is, let's look at the whole message. Gender coded as gender. We were not ready for this. Please contact the IT department. So when do I think that we're going to begin to code a gender more in a more nuanced way when doing insurance premiums? Well, when insurers find a way to use that to their economic advantage, right? So if being respectful of a more nuanced gender identity is a way to get more customers, well, then they're going to come around faster, right? But in any case, if our code assumes that people are going to be grouped into male or female, and they're not anymore, again, this is probably the case where the company has said, oh, you know what? By being a little more woke here and giving a whole group of people more respect than we were giving them before, we're going to make a little bit more money. Isn't that always the motivator for for-profit enterprises? Okay. And so what they've done is they've changed the system. And let's assume that it's coming in as non-binary. Okay. So we now have three values that something can be coded to, right? But nobody remembered to come and change our little program. So our little program is not going to fail silently. It's going to blow up, and then somebody in the IT department is going to go, "Oh, nobody ever changed this program. We've got to get, the information in here for non-binary rates." Okay, so then within that, we decide upon the age. So if the age is less than 25 for male, the premium is 200, else 160. So younger drivers pay more. And then for the female, if the age is less than 25, premium's 100, else 70. Okay, and are these realistic? No, they're not. Probably uh, uh, on the male side, if the age is less than 25, it probably would be double what it would be. I don't know. Okay. And then in any case, we're going to print out the answer. So let's play with this and run it. Okay. So, and this is another kind of testing. Okay. And the kind of testing that we're doing here, we call it unit testing. And what do we mean by unit testing? Well, unit testing is testing a unit of code. So the way that we write our code is we write it a program at a time. So the testing that we've been doing is unit testing. Okay. And in this case, instead of prompting the user for these things, I just hard coded them in here. Okay. Now, what would this mean? Well, this would mean is each time I run it, I'm going to have to change the program. So we see the answer down here for female and 17. Female applicant at age 17 it pays $100 premium. Okay. And then let's change it to female. Let's make this female 25. Okay, and we'll run it again. Okay. Okay, so then it's 70. So 100 or 70, and then we could make it male and 25. So let's see what we get there. We get 160. That's good. And then if we change it again, male and 24, right? That's just under the boundary. Okay, we're doing some boundary value testing. So that's 200. Okay, that looks good. And then what happened if all of a sudden we've decided to be a little more woke and we're recognizing non-binary people now because we found a way to show a little more respect and have that work into our money-making scheme. Okay, and now we're going to give this a run, and it's going to blow up. And we'll talk about the mechanics of that in a couple minutes. But then it says value error, gender coded as non-binary. We were not ready for this. Please contact the IT department. So what's the IT department going to do? They're going to go, oh, we forgot to change this program. Let's go change it and get it back working again. All right? So that's what's going on here. Now, I just want to point out that there are a lot of ways to do unit tests, okay? And this is kind of a half measure, okay? So are we going to be unit testing like this, where we're changing the program every time we run a test case? We're going to be doing that long? No, we're not. In fact, real soon we're going to show you another version that kind of is a little more promising. Okay, so that was number 30. Okay, now let's look at number 35. Okay, nested in function. Okay, now I'm showing you another style of unit testing. Okay, I think we actually do this in a homework exercise, so I'll talk through this a little bit more. So here we go. So the code that determines the premium is now factored into a function, okay? And I just want to point out that I think that it's more useful when it's factored into a function. One, it's not cluttering up whatever code it's in, right? Now, it wasn't really cluttering up this uh, um, it wasn't really cluttering up this unit testing code too badly, right? But here, uh, we've given it a name, determined premium. It takes two parameters, age and gender. It's a lot easier to see that now, okay? And what does it return? Well, it returns the premium, okay? So it's better documentation. It doesn't clutter up the program as well. But the code inside of it is the same, okay? So this allows us to write more summarized code at the top, right? So here's another way that we're going to do unit test. Is it the most sophisticated way that people do unit tests? No, it's not. One way that people do unit tests, and I'll take you there. Okay. Um, uh, they use these things called unit testing frameworks. So Python unit testing framework. Okay. And there are two really popular ones. One's called unit test. And if you want to know more about it, it's implemented with a Python package called unit test. Okay. There's another one called PyTest. And see where we can find them. There's a whole bunch of them. Here's one: top 6 Python testing frameworks. So, here's another one: top 8 testing frameworks. Okay, so that's a lot. All right. Now, are we ever going to get to a formal unit testing framework? No, we're not. Why? Well, that's good. Just learning the details of using a formal unit testing framework would chew up a whole week of the course, and it's typically not considered a beginner skill. It's typically considered an intermediate skill. So we're going to take some approaches that kind of emulate what people do with these unit testing frameworks. And this is our first step towards that emulation. Okay. So one, we're going to print summarized output that shows us the result of the test. Okay. And each of these things that we print, you can think of them, it's called a test case. Okay. And a test case works like this. you specify the input, and you predict the output. Okay, so here's what we're saying. We're saying that if we call determine premium with 18 and male, we're expecting the output of 200. Okay, that's what we're saying there. Okay, so what's interesting is that because we use this equal, because this is a comparison, okay, let me put everything but that into a comment. Because what we're printing is a comparison, it's going to come out true or false. So if this test case passes, okay, if calling determine premium with 18 and male actually returns a value of 200, this is going to be true. And when we say print this, we're going to print true. So let's look. True. Okay. And formal unit testing frameworks do something like this. They do, when you run them in IDEs, they typically print out an extending bar of either green or red. So every time you pass a test case that passed, you get a little bit more green bar. So when everything's going well, you get growing green bar. It's almost like a progress bar. And then when you hit one that fails, boom, it turns red. Okay. Well, here what we're doing is that we're taking all these test cases, right? And let me toggle these back out of a comment. Okay. Then when we run them, if they passed, we're expecting them to be true. That's pretty cool. Okay, so let's say the 1, 2, 3, fourth one came back false. Well, then we could go back into our program and go 1, 2, 3, 4. Well, there's something about this that didn't pass the test. Okay, now the other thing that we have is, what if our code raises exceptions? Okay, what if it blows itself up? Well, the problem is there that kind of ruins the whole thing. Okay, because when we ran the tests without the exception condition, it was really pretty true. But if we turn this, if we take this one that calls with the non-binary, okay, that's going to blow up. Okay, so let's run that. Okay, and we can kind of see it was true, and then it blew up. Well, that's okay. Okay, sometimes what I'll do is I'll run the passing cases, and then I'll put them into a comment, and then I'll turn the one that blows it up, I'll take that out of a comment. But generally speaking, I think this is still pretty readable. Okay. Programmers who are using formal unit testing frameworks are able to actually catch code that blows up and consider them a passed test. Because really, even though it's in the data, it's an error condition, we're expecting this to blow up. So that test actually passed, although there wasn't a good way to get it to print true. Okay? So there we are. Now, we're not going to adopt this approach to unit testing for long. Okay? In fact, I think in the next chapter, I show you an even more sophisticated version that, again, it's not one of these unit testing framework packages, but it's this little code that I give you to help to do this without us having to take a whole week or two to learn formal unit testing frameworks. All right, so that was 35. All right. What's next? Try except blocks. Okay, so we just saw a code that raises an exception, okay? And we've seen a lot of exceptions in our testing before. If we made a really big mistake, maybe the program blew up, right? And when the program blows up, it prints this thing that we call a stack trace. So this thing down here, down at the bottom, it's loosely called a stack trace. And the stack has to do with the stack is a kind of programming internalist way to keep track of what called what called what called what. And these print out in the order. They'll say you ran into a problem at this point here. Okay, that was called from this point here. And that was called from this point here. Yeah. Yeah. So I said it exactly backwards. So uh, where where the code is actually executing is always the lowest of these blue um, links. Okay, so we were in line 34. And let's just look what's on line 34. Yep, right there. That's where we blew it up. And we were called from line 19 in main. Let's see where that is. Yep, we were called right there on line 19 in main. And that was in our module. That was in our program. Okay, so there's a stack of these. That's how you find your way to where you came from, right? And typically for us, our problem is going to be right where we are now. And something that I haven't emphasized a lot, but you can go to one of these stack traces and just take the lowest blue link and click on it, and it will take you to the line of code that blew up. Okay, so that's what we mean when we say a stack trace. Okay. Okay, and there'll be a slight pause while I find my slide. Found it. Okay, so back to the slide. So uh, using these things called try except blocks, we can recover from anticipated program exceptions. So we've seen that program exceptions get raised, okay? And up until now, we've seen it just end and print the stack trace, right? But we can catch it with a try except block, and we can try to recover gracefully. Okay, so we just don't have to. We don't have to take it that any time that there is a program exception that we're automatically going to blow up. We can catch it with the try except block and try to either exit the program gracefully or recover. So the try block, that's the first part. It contains the code that might raise an exception. Okay. You have one or more except blocks. They contain code that detects the exceptions and handles them. And by handling them, it can handle them in two different ways. One, it can note the problem and end the program gracefully, or two, it could recover from them. And then there's another block that doesn't get talked about a lot. It's called the finally block. We only have one of those, and it allows for some code to run regardless of whether an exception was raised or not. So there are some times that we want some code to execute whether whether we blew it up or not. And this is typically things, I call it putting away your toys, but you might have some files open that you want to close, or you might have a database connection open that you want to return. So the kind of thing that goes in a finally block, I call humorously putting away your toys. Okay, so let's take a look at some code that does this. We've got a 40 and a 43, 40 try and 43 try with called code. Okay, so let's look at those. So I'm going to close those folks and open 40 try. Okay, and so up until now, we haven't really paid a lot of attention to whether our code can lead to raised exceptions or not. But one of the things that we've seen, or we should have seen, is let's say we prompt the user to enter an integer like we are here on line 8, and then we tried to convert it to an int using a call to int. Okay, if we have a non-int value in the string that came in from the user, something like "Hi mom," well then it's going to raise a value error. Okay, and it's going to blow up. So we know that that can happen. So what if we want to catch that? And a lot of times we want to catch that just for usability. What if we want to just reprompt the user? Okay, we don't have everything that we need to that, but after we get through chapter 8, when we get to chapter 8, we're going to have all the looping that we need to just keep prompting the user till they give us a proper integer. Which is a much more usable program. So to do that, we have to be able to catch these kinds of exceptions. Okay, so the first part is to put the code that can raise an exception into the try block. So here we prompt the user, we convert the string to an int, and then we print you have entered the integer, and then we give the value. And the code that could raise an exception is this call to int. Okay. So typically in the try block, you have an entire block of code that accomplishes some important action for the program. And typically the thing that might raise the exception is not the last thing. Okay, so if there's no exceptions, well, we just run the try and then we're done. Okay. If we and then we can have an except block for every potential let's see, for every exception that might be raised that we want to handle. Okay, so if they typed in "Hi mom," we know that we're going to get a value error. Okay, and so we catch it, and then we can print an integer was expected, you entered, and we say we enter. And at this point, because we don't have the looping constructs to keep reprompting, we're just going to stop here. And we're going to show you how to end a program gracefully without having it go all the way to the end. And one of the things that you can do is from the Python sys package. That's one of the packages in the Python standard library. we can import exit, and then we can just say exit. We call the function exit, and then we gracefully stop the program. And then, of course, we say, thanks for playing. Now, at this point, we don't have a finally, okay? And we're only catching value errors, okay? If there turns out to be some other kind of error that comes up in this code that's inside the try, it's just going to blow up, okay? We're not going to catch it, okay? In some languages, these are called try-catch blocks, and they use the word catch here. The Python, the mothers and fathers of Python decided that we're going to have the word except here, and that makes, I think, some syntactic kind of sense. But even though we don't use the word catch here, we call this catching exceptions. So each except block catches one or more exceptions. If you want that block to catch more than one, you have a list separated by commas. So let's run this. Okay, so it says please enter an integer. So let's enter 222. And then it says you've entered the integer 222. Thanks for playing. That's good. And then we run it again. Okay, and we say, please enter an integer, and I say, hi, Mom. And it says, an integer was expected, you entered hi, Mom, program is ending, please run it again with the proper input, okay? You'll notice we never got to thanks for playing, okay? Because if you use this call to exit from the sys package, you just end the program dead right here. It never continues on. All right, so that's that one. Let's go and look at 43, try with called code. Okay, so I'm trying to show you another couple of features here, okay? First of all, okay, when you put code into a try block, it doesn't have to raise the exception itself. It could have called a function that causes an exception to be raised, okay? So in this case, we have a function called get my integer from user, okay, and it has the code. So it prompts the user for an integer and calls int on it. So if we type up hi mom, the exception is going to be raised here, okay, and that would normally cause the program to blow up. But what happens is Python looks up the chain of what called what, and if it finds a try except that's catching what got raised, well, it'll catch it up here, which is really, really nice. Okay, so here, we call the function that it gets the value from the user, and then we print it, okay? We catch the value error, and we do the same thing. Note that there's a finally, okay? And I say, let's put our toys away before we leave. And I say that humorously, but that's essentially what you do in a finally. If you've got resources like files open or database connections open, this is a way to make sure you have an opportunity to close them. And then we print thanks for playing. Again, we should expect to see thanks for playing only if there's no error. Okay, if there's an error, we expect to trigger a value error and leave with exit. Okay, the finally we're going to expect every time. Okay, finally is going to run um, at the end of this. So um, it'll run even after exit. That actually runs before exit, but before it will exit, uh, it'll run the finally. So let's look at this behavior. So please enter an integer 9999. You've entered integer 9999. Let's put our toys away before we leave. So you always run the finally. Thanks for playing. That's fine. We went all the way to the end. And then please enter an integer. Hi, Mom. Okay, an integer was expected. Program is ending. Please run it again with proper input. Let's put our toys away before we leave. So even though we blew it up, okay, we will run the finally. And again, it really is for metaphorically putting your toys away before you leave. Okay. All right. Well, I'm going to take a pause here and I'll be right back. I might suggest that you do the same. Okay. I'm back from my break and I'm hoping that you are too. Okay, so let's go on and let's learn how to use this feature of signaling error conditions. Let's learn how to use it in our own code, okay? So, in fact, I showed it a couple of these programs ago. I showed an example of using this, maybe a little bit early in the lecture, but now we're going to get down to how to do it. So, in our own coding, when appropriate circumstances arise, we can raise exceptions in our own code, okay? And it's a really cool feature. So the architecture of this is brilliant because it separates the detecting of errors from the handling of them. So generally speaking, it allows the call code to detect the error and raise an exception. And it allows the calling code, as long as we wrap the calling code in a try except block, then the calling code can handle them. And if you do just a little more thinking, you realize how brilliant this is. Because before we had constructs like this in programming, people would try to handle problems in called code. And the difficulty is, in order to do that, then called functions have to know too much about the code that's calling them. And this, we say that functions should have high cohesion and low coupling. Well, a function knowing too much about the business of the code that calls them leads to too high of coupling. And so now the called function only has to know that some kind of error has occurred. It doesn't know how to handle it, or even if it can be handled, right? So it raises the exception, and then the calling code, depending upon whether or not it thinks it's possible to recover from errors like that, will either put that calling code in a try except block or not, right? If there's no way to recover from it, well, just have the code there all by itself and the program will blow up. So the way that we implement exceptions is with Python classes. So these exceptions are uh, uh, actually classes. So normally when we raise exceptions, we just reuse the built-in Python exception classes. So I have a link here to the Python documentation, and I'll pull that over. And there are a bunch of built-in exceptions, and you can find them. Okay, and it's a hierarchy of classes and all that kind of stuff. But for instance, um, one that we use a lot is value error. And it's probably in alphabetical order here. So it's probably overflow error, runtime error, that kind of stuff. Two really popular ones. I didn't see value error, but two really popular ones we can use. If somebody passes us a value that just is inappropriate, we can raise a value error. And the other one that's really popular is runtime error. If something has gone wrong that we weren't expecting or we don't know how to recover from, well, we can characterize it as a runtime error. Okay? Uh, uh, or it's possible to create your own custom Python error classes. Okay, that's not something we do in this course, but I point you to a tutorial article on how to do that. And I'll bring that over here. That's an article in Geeks for Geeks. Okay, one of the tutorial sites. Okay, so let's explore this more in 45 rays. Okay, so let's open 45 rays and close this thing here. So, one of the things we've done here is we've taken the lookup code that we used earlier in the lecture, and we've decided that instead of passing back a region name that says region error, okay, and when you really think about it, is region error really a region name? No, it's not. Okay, so we've kind of cleaned up this function lookup region name, whereas it only passes back a region name if it has a proper region code. Else, instead of passing back a phony region name to signal that there's been an error, it raises a value error. Okay, and every time you raise an exception, you can pass it a string, and that's the string that gets displayed in the stack trace. Okay, so when you raise this, it's going to say region code must be 1, 2, 3, or 4. This value is whatever. So we'd sum this, if we passed it at 0, it would say this value is 0. Okay. And then the calling code can catch it. Okay, so let's look at that. Well, first of all, in the try block, this is code that we used before. Okay, we prompt the user to enter the region code. We convert it to int. Okay, this is the code that this is code that can raise a problem. Okay. Then we call lookup region name. That can raise a problem as well. Okay. But if those two things go well, then we print out the answer. Now, we say except value error, so it'll only catch a value error. If we get another kind of error, it's just going to blow up. We're not going to be able to get control. And if you want every exception okay, is an instance of that class. So if we have a valueArr exception, there's a valueArr object, okay? And how can we get access to it? Well, we use this as, and then we give a variable name. So the variable name that we typically use is a combination of lowercase letters that correspond to the first letter in of the words in the class name. Now, class names, as you see here, are in camel case. So valueArr VE. So we say accept valueArr as VE. So what's VE? It is the exception object. Okay, so what can we do is, well, we can say that we're going to print, okay, we're going to skip a line and then we're going to print VE. Well, it turns out when you print an exception object, it will show you the string associated with the error. Okay, so let's look at this. And then here we say thanks for playing. Okay, so we don't really recover from the error. We just print information that would be useful. All right, so let's give this a run and look at a couple of things. First of all, let's give it some valid values. So 1's a valid value. Region code 1 is Northeast. Thanks for playing. Okay, and then we'll do the other boundary value, 4. Okay, region code 4 is Southwest. Thanks for playing. Okay, now let's do 0. Region code must be 1, 2, 3, or 4. This value is 0. Thanks for playing. Now, what's interesting about being able to print the value of the message in the exception is that even if you're not going to allow this thing to blow up, you can still get access to the message. This is the message that you would have seen if it really blew up. Okay? That's what we're doing with this print. And in order to be able to do this, one is we have to do the print, but we also have to use this as VE, so we've got something to print. Okay, that's good. So value 0 is going to do that, probably value 5 as well. Okay, yeah, that looks the same thing. What if we type in hi mom? Invalid literal for int with base 10 hi mom. So this is nothing that we detected. Okay, this isn't us raising the valueArr. This is things going wrong in the call to int. But it's a useful message. How about that? Okay, so and what's interesting here again is, and this is a brilliant architecture, and I can only say this because I worked with languages that didn't have this for a very long time, right? But this separates the detection of the error, which happens in the call code, with the decision on how to handle the error, which happens in the calling code. And because of that, the call code, it doesn't get all coupled with the calling code. It's a brilliant scheme. All right. Enough for raising exceptions. We've got a couple more things to talk about. Something that is talked about a little bit in the text, and I just want to amplify and tell you more about, is finding the lowest, the highest, the longest, the shortest of anything. Now, this is most easily done if you have the data in a list. Once you put the data into a list, you can use the built-in functions min and max in order to get the values that you want. Okay, but what if they're not in a list? Okay, well, one of the things that you could do would be to take the data and put them into a list. Then you could use min or max. Okay, fine. Okay, but some files, and when I said what if they're not in a list, I mean what if they're in a file, right? Some files are just too long to go into a list. Okay, they won't fit into the memory. Okay, so what we want to practice here is imagining that we have that kind of use case, and we want to be able to go through the file one entry, one line at a time, and find the highest or the lowest or the longest or the shortest. Okay, and there's a very popular design pattern for doing so, and we're going to show that in a minute. Now, the design pattern requires that the programmer know how to express very high and very low values. Here are some references on how that's done for particular value types. And the ones that we're probably the most interested in for this are int and float. So if we're trying to find the highest int or the lowest int, well then we'll go here and find what we're looking for. If we're trying to do it for float, we go here. So, and I'll come back to show you this in just a second. Okay. All right. So let's close these and go to look at 50 find lowest. Okay. So the interesting thing is that before you start reading a file, you don't know what the highest value is, or what the lowest value is. So there's a programmer trick that says that we set. Here we're looking for the lowest, okay? So there's a programmer trick that says that we're going to take the lowest value so far and we're going to set it to the max integer value. So we're working with ints, okay? All right, why is that? Well, we want to make sure that as we're going through the file, the first line that we read is going to be lower than our lowest entry so far. This is why it's a programmer trick. Well, why? How could we be sure that the first one is going to get chosen as the lowest entry so far? Well, because there is no higher value than the max int value. Okay. Okay, so if you're doing the opposite, if you're trying to find the highest entry so far, then you're going to send highest entry so far to the min int value. Okay? And again, don't think about it too hard. It's a programmer trick. It just works. Okay? So then the question is, how do you find the min int value or the max int value? In this case, we're looking for max int value. We made that a constant. We use the name max size. That comes from the sys package of the Python standard libraries. Back to the slides. Okay, so I have a reference here for int, and it's a Geeks for Geeks thing. So let's come over here. Okay, and it's telling you, it's talking about a couple ways to do this. Now, there's a difference in how to do this for Python 2 and for Python 3. So here's what I'm going to tell you about Python 2. Don't use Python 2. Python 2 is dead. Okay? Use the Python 3. Python 3 is living. Python 3 has uh, arbitrarily large ints. So it's very hard to make an int larger than Python 3 can store. But any given implementation of Python 3 has a maximum size that it will allow for ints. Okay, and if we look at this, um, we have an example here where this gal, this person, um, they, we should say they are trying to find the lowest value here. So what do? They import sys, and what they do is that they, no, I'm sorry, that's the Python 2. Let's look at the Python 3. Python 3, yeah. Import sys, it still comes from sys, but in a Python 3 implementation, the max int is sys dot max size, so it's in the variable max size, and the min int is in you get it by saying sys dot max size minus 1. Now why that works? Well, it's because of the way that the number representation wraps around. So when you get to the largest one, uh, if you um, if you subtract 1, then it's going to do it. Okay? So that's how you do it. Okay, so this is, you're looking in this article under Python 3. Okay? And using sys.maxsize. Okay, so that's what we've got. So here, got to take a couple of things off of our program. Okay, here we're using max size. Now, why doesn't it say sys dot max size? Well, if we just had said import sys, then every time we used one of the variables in it, we'd have to prefix it with sys dot. If we use the more preferred from sys import max size, then we can just use the variable name as though we defined it in our program. Okay, so the max int value is max size. Okay, and if we are looking for the min, it'd be, at least according to the article that we have here, oh, I lost it. I lost it. It'd be, oh, I brought over the wrong thing. Even I'm getting tired. It would be sys dot max size minus 1. All right. All right. Now, how does the rest of it work? Well, a couple of things. We need to count the lines. And why is that? Well, we need to count lines because we need to know if we didn't read any data. If we didn't read any data, there's no reasonable answer for what's the lowest value. So while we're reading the file, we're incrementing the line count. So at the end, we're going to say if the line count is still 0, then we're going to print the input file is empty, else we're going to print how many entries were in the list and what's the lowest entry so far. Okay, so that's the first thing to know. And then we set the lowest entry so far to this maxed int value. That means when we get into our loop, okay, the first one that we read is definitely going to be lower than that. Okay, so when we test, if entry is lower than lowest entry so far, it will be, and we're going to move the entry into lowest entry so far. Okay, this code here about how to open the input file, well, we've been using that a long time. I'm not going to go over it. But again, why are we going through the file instead of using a list and using, in this case, min? Well, we're pretending that we can't fit all the values into memory. Now that would be a very big file, but there are files that are bigger than what you can fit into a list without blowing up your program on a memory error. So for each line, we're going to count it. Okay, we're going to call int to turn the line into an int, a value that we're going to call entry. Even though there's a line feed, there's a new line at the end of the line, int is robust enough that it can digest it. And then each time we're going to ask if the entry is lower than the lowest entry so far, then make the entry the lowest entry so far. And then when we get done, we know what the lowest entry so far is. So in terms of testing this, we've got two files, empty file and integer values .text. So let's give it a run. So we're going to give it a run. So first, let's do empty file. Okay, it found that it was empty. And let's run it again, and let's do integer values dot text. And it was a -2048. So it works just as we would expect. Okay, let's move on. Okay, another common use of ifs is for validating input. And it's not too hard to imagine if you're just going to check a value, whether it's lower than some boundary or higher than some boundary. That's not hard to figure out. What I want to show you now is a pattern that we have for something that I call multifaceted validation. Okay, so you get some input, and let's say a person has to have certain qualities. In fact, in the example that we have here, we're at an amusement park, and a patron of the park has to have certain qualities in order to qualify to ride the attraction. Okay, and so we're going to be validating more than one thing. Okay, and each of those things that we validate is a facet of the validation. So multifaceted validation can be implemented using a series of if statements. In this design pattern, we usually begin by assuming that the input is valid. Okay, then each facet is tested in turn. A failure of any one test, so a test for any of the facets, makes the input invalid. So we've got three implementations of this. 70 using S for validation, 75 validation using a function. It's almost always a good thing to take a block of code that does one thing and refactor it into a named function. And then 80 validation using function and messages. This is a further pattern that's very popular, and we're going to be doing it in some of our assignments. Okay, so 70, 75, and 80. Alrighty. So in 70, here's the thing. We have some kind of attraction at amusement park or a theme park. It might be a roller coaster or something like that. And the rules are, oh, this one's called Killer Mountain. I guess it's some kind of a roller coaster. Guests may ride this attraction if they're at least 6 years old and less than 90 years old. Guests may ride this attraction if they weigh at least 50 pounds and less than 300 pounds. Okay? Um, we prompt the user for the guest's age. We prompt the user for the guest's weight. Okay. We don't have the code here to recover from non-int responses, but you know that we can, right? We're just not emphasizing that here. So, as I mentioned on the slide, it's typical to assume at the beginning that that the data is valid, okay? And that means that the guest is qualified to run, okay? Pretty typically good to implement that with a Boolean value true. And then we start to test, right? So we've got two tests. We have to test the age. Well, we've got two facets. So we've got the age facet, and then we've got the weight facet, right? So in the age, if age is less than 6, guest qualified gets assigned false. If age is greater than or equal to 90, guest qualified gets assigned false. Now, you'll see people who just have individual ifs. So they'll have a simple if and a simple if. Okay? And I think the first version of this program that I had two simple ifs. Now, it's a little bit more efficient and it's better a documentation to use an elif because if the guess is less than 6, there's no way that they're greater than or equal to 90. Okay, so there's no reason to test that too. Okay, likewise, when we go on to the facet of the weight, if the weight is less than 50, there's no way that the weight is greater than or equal to 300. So no reason to test that either. So each of the facets is measured by this if-elif. You'll notice that these if-elifs don't have an else. And this is pretty typical when we've got numeric input, okay? And we're dividing it into ranges. And these ranges are open-ended. There's no possible else, okay? And then when we're done, we say if guest qualified, okay? And this is the truthiness way to test a Boolean. Could you say if a guest qualified equal true? Yeah, you could, but that's not considered good form. The good form for Booleans is to always use this kind of truthiness syntax. So if they're qualified, we print this guest may ride the attraction, else this guest may not ride the attraction. So we run this, okay, and let's do some things that are outside the boundaries. So enter the guest's age. Let's say that they're 5, okay, and enter the guest's weight. Let's say they only weigh 45 pounds. They may not ride the attraction, okay, and then let's say that they qualify on age but not weight. So let's say that they're 6, okay, but they're only 49 pounds. Well, they may not. and then, we work our way through. Okay, so the key elements of this pattern are we have a series of statements that each of them is going to test one of the facets, okay? And we begin by assuming that we've got valid or passing data, and then each time we test for an error, because you have to pass all of the tests, you can say it's equal to false. Okay? So that's how you do it if you're coding it inline. You can imagine that this can really begin to take up a lot of room in your code. So it's really good to, to factor this into a function. Okay, so this 75 is the same code where we've taken the testing and we've refactored it using refactor extract method. And normally, when we have a function that returns a Boolean, okay, we give it a name that's kind of a question, like is qualified guest, okay, and then it's going to come back true or false. And again, I like the fact that now it's named. Okay. I like the fact that we can see the parameters explicitly. And I like the fact that we return the value. Okay. I will point out that you'll see coders who will code a return on each of these lines. So instead of having one return at the bottom based upon a variable, they'll have 1, 2, 3, 4 of those. We can talk about that some more when we're in class, but I prefer this. Under the stricter programming rules with which I was trained, this was the way to do it. Okay? I'm not saying that the other way is wrong. I'm just saying that it's not what I prefer. Okay? And then the code, the calling code, is essentially all the same, but we've taken all this logic out of the middle and we've replaced it to just one call to is qualified guest. And if we run this, we can say that, let's say we've got a person who is 50 and they weigh 150 pounds, and yes, they may ride the attraction. Okay? Now, I'm going to show you one more way to do this that's very popular. So this is a further way to do this. It's very popular when we're validating input, and it works like this. Okay. If we go back to the way we just did this, okay, we're not saying, well, I'm sorry. Why don't we back up to where we were and we'll run this. We'll run it one more time. Okay. So we enter the guest age and we say 3. Okay. And we enter the guest weights. We'll say that this 3-year-old weighs 333 pounds. So they're going to fail on both. And it's going to say this guest may not ride the attraction. But the problem is, what if they ask you why? Okay. Well, you've got 2 reasons and you're not really saying why. Now, if you're really the attendant at Disney World, okay, well, you know what the rules are. All right. But let's say this were some kind of a web application and the users were filling out a form. This is a thing that happens all the time. And you fill out the form, and in a very frustrating way, you fill out the form and you you click the submit button and you get one error back. And then you fix that and you click again and you get another error back. And then you fix that. And then it can be 2 or 3 or 4 times. And what's frustrating is what you would like to do is the first time you click the submit, you'd like to get something back that says, you made these 4 mistakes. And then you can fix all 4 of them. And then the next time you click submit, it gets accepted. Okay. Well, this is a way to maintain a positive relationship with your user. So giving these errors to the user one at a time is a way to wear them out. Every time you tell them they made a mistake, you hurt their feelings a little bit. And if you tell them 4 times in a row, well, they compound each other, so you hurt their feelings a lot. Okay, so what we're going to try to do here on this this 80 validation using function and messages is we're going to save all the error messages in a list. Okay, and we're going to know if we have an empty list, then there were no errors. Okay, and if we have a list that has contents, then we had errors and we're going to report them. Okay, so we have an is qualified guest. Okay, oh, I'm sorry, we're looking at the wrong one. Okay, so here's the function that we're calling check guess qualifications. So again, we pass it age and weight. Okay, and what do we pass back? Well, we pass back a list of error messages. Okay, it starts out empty. Okay, and as we go through the validation, okay, we're not turning a Boolean true or false. Okay, what we're doing is whenever we find an error, we append it to the list of error messages so that when we get done, if error messages is empty, well, then they qualify. If there's at least one message in error messages, then they don't qualify. But then we can print the list and give the user a comprehensive list of all the problems that they need to fix. Okay, so again, each facet can be done with an if-elif. Okay, and then instead of simply turning on, turning the valid indicator to false, we append the message. Okay, and then in terms of calling that, well, all the prompting of the user is the same. Okay, and we call the functions with the age and the weight. Okay, but we're getting back a list called errors. Okay, and here we can say if the length of errors equals 0, then we print this. Else, we print this guest may not ride the attraction due to the following reasons, and then we print a list of them. Now, I want to point out that here we've used the explicit syntax and not the truthiness syntax. Okay, we could have said if errors. Okay, that's the truthiness syntax for that. Okay, you're going to decide your style, but you ought to be able to recognize the other one. Okay, so let's give this a run. So again, please enter the guest's age. Let's say that they're 4 and they weigh 45 pounds. may not ride the attraction. The guest must be at least 6, must weigh at least 50 pounds. Okay? And we can go off at the other end. We can say that they're 90 and they weigh 301 pounds and must be no more than 89 years old, must weigh less than 300 pounds. Well, it was off by 1. Or we can say the guest age is 16 and they weigh 135 pounds, and yet the guests may ride the attraction. Okay, so which is a little bit of care in this trick of using a list of messages to represent, the validity or invalidity of the data. You can just improve usability dramatically. Okay, I promise you we're getting close to done. Okay, now we've come to these extra Python features, and of course I talk about these as syntactic sugar because all the features here are things that we can do with the features that we've already learned. It's just using these features is easier or more appealing to some. Okay? So, the big one is called structural pattern matching. Okay? So, in a lot of languages, we have this thing called a switch or a case statement, but we have never had one in Python until Python 3.10. So, if you want to know about the history of these kinds of features in other languages, you can follow this link to the Wikipedia article, and it calls it a switch statement because that's what it's called in the C language, and the C language was one of the earlier implementations of this kind of construct. Okay, this is new in Python 3.10. What we're talking about here is using this structural pattern matching in its simplest form, and as such, it's a substitute for the multi-way if. Okay, I just want to clue you in that structural pattern matching is such a robust and exciting feature that it implements potentially much more. It's more powerful than the multi-way if by far. And if you wanted to go explore all the kinds of things you can do with structural pattern matching, there's a tutorial that's part of the Python documentation that's extensive. And you can really do a lot of cool stuff. Okay? I've got 2 versions here. And what we're going to do is we're going to say we could use it to do a lookup, right? We've been doing lookups using the multi-way, the if, elif, else, right? Well, we could do it using structural pattern matching, and we could refactor that into a function. So this is going to be 90 and 92. Let's take a look. Let's close all these guys and open up 90. Okay, so this is the old look up the region code. Okay, and there's a question of what do you want to do when it's invalid, right? And one is you can report back just invalid region as the value for region name. The other thing is you could raise an exception. Well, I didn't want this to be too complicated, so here we're going to pass back invalid region. So how does this work? Well, we're prompting the user for the region code in the same old way, and we're converting it to an int. Okay. And then for each value that we want to match, we have a case. So we begin with match, and then we have the name of the variable region code. And then we have a case for each of the values that we want to match. So in the case that it's 1, well, we want to assign northeast to region name. 2, southeast to region name. 3, northwest. 4, southwest. What's this underscore value? Well, this is the equivalent of an else. This will catch everything that hasn't been matched so far. Now, I don't think this is the greatest syntax that they chose for this. I probably would have rather seen an else, but this is the way it works. Okay. So for everything else, we're going to catch with this underscore value, and we're going to give it region name invalid region. So let's give it a run. Okay. So let's give it a 1, northeast. Let's give it a 4, southwest. Let's go on the other side of the low boundary, 0, invalid region. And 5, invalid region. Okay. So that works the same as the other one. Okay. Which should you prefer? I think you can use either of these. I think this is good code as of Python 3.10, and so is the if, elif, else version. Whether people are going to come to prefer this, we don't know. They're just getting a chance to use it right now. Okay. And it would be possible if you wanted to put a return under each of the cases instead of oh, I'm sorry. This isn't a function. We've not factored this out, so that doesn't apply here, but it'll apply to the next one. So never mind on that, but let's go on to the next one, which is 92. This is the same code refactored into a function, right? So again, we prompted the user. We did a call to lookup region name. Again, factoring it into the function, it's a lot easier to see what this code does rather than then just jumping into the code. Okay. The other thing is that you know what data gets considered because you know what the input parameter is. Okay, I like that too. Other than that, the code's pretty much the same as the one that's coded in line. And again, the question arises for some people: do they want to put a return in each case? I was taught that each code entity ought to have one entry and one exit, and so this does that. Okay, and putting a return on each of these is really going against that. It's probably true that in today's programming world, people are not so concerned as they once were about each function having only one entry and one exit. But there still are plenty of us like me who are. So I prefer the one that just has a single return. I think this is a cleaner version of the code. All right, we're almost done. Okay, I think this is the last one. Yeah, this is the last one. So there's another extra feature called the ternary if. Okay, a ternary means three part. Okay, so when we finally see it, we're going to see that the if has three parts. Okay, so uh, I, I call this a topic, easier message formatting with a ternary if. Sometimes we want to format an output message that is slightly different depending upon data values. A classic example of this is when we want the message to include plural or singular terms based upon data values. So we want to say something like, Kevin has 0 potatoes. Kevin has 1 potato. Kevin has 3 potatoes. Okay, so we want to customize the message to be either plural or singular. Okay, and there are a lot of other use cases for this. So this is possible using a two-way if, but it's a little bulky. Um, and a lot of people think that it's easier to code using the ternary if, and I want to show you this. Okay, so I'm going to show it to you both ways. 94 is formatting without the ternary if, and 96 is formatting with the ternary if. And again, ternary means three part. Okay, so here's a classic situation. We're going to prompt the users, please enter your name. And then we're going to prompt the user, please enter the count of strawberries that you picked. Perhaps we're a strawberry farm, pick your own. And then we want to customize the output. So here's what we do. We use the classic if-else in order to populate the text that we're going to use. So if the count is 1, then we're going to use strawberry. Else, we're going to use strawberries. And then we're going to print name, picked, count, and then we're going to use the text today. So Kevin picked 1 strawberry today. Kevin picked 3 strawberries today. So let's look at this. And this works. Okay, so we're going to enter my name, Kevin. How many strawberries did I pick? 1. Kevin picked 1 strawberry today. Yeah, that looks good. And then I'm going to run it again. And the one that eludes some people is when it's 0, because we use the plural name for that, which is, what the rationale for that is in proper English, I don't know. So let's say Kevin again, and let's say 0. And now it says Kevin picked 0 strawberries today. So that behaved the right way, but that's a lot of pre-calculating. A lot of people think, well, that kind of pre-calculating is clumsy, right? So there's a ternary. So this is just in this kind of early version in 94, we're just using the regular if. Okay, the if else. And then if we come down here to 96, the ternary if. The ternary if has 3 parts, okay? And we can code them inline. So instead of pre-calculating a variable with the classic if else, well, we can put the code right in line. Okay, so in here, we have 3 parts. So part 1 is the value if true. Okay. Part 2 is the test. Okay. If count equal 1. And then part 3, depending upon how you count the parts, is the assignment of the value if false. So 1, 2, 3 parts ternary. So we say strawberry if count equal 1, else strawberries. Okay, and what's interesting is if you're coding it into one of these curly braces in an F string, this looks pretty good. Remember that if you've enclosed the F string in single quote apostrophes, then when you use these strings inside of the curly braces, these have to be in double quotes. And of course, if you had the F string in the double quotes, then the interior strings would have to be in single quotes. Okay, so again, 1 part, value if true. Some people I think would say that the 2 parts is, the test, and they would say that the 3rd part is the value if false. So how you count the 3 parts really doesn't matter. There are 3 parts. So let's run this. Okay, so here's my name, Kevin. And how many strawberries that you picked? 1. Kevin picked 1 strawberry today. And now I'll give a really plural number. So my name is Kevin, and I picked 999 strawberries. Kevin picked 999 strawberries today. So again, do we need this feature? No, because we can pre-calculate this with a regular old if, works fine, reads well. Okay, but this is the classic syntactic sugar extra feature, because a lot of people would say that this reads better. Okay, now I think the extent that the strings get longer, to the extent that the values get longer, then it gets harder to read. Okay, so if the true value and the false value were very long, then I think this ternary version of the if would read worse than the classic if else. Okay, so but for just strawberry versus strawberries, I think this is very nice. Okay, and feel free to use it. So that is the end of the Beyond the Textbook lecture. I'm going to say bye until next time. Bye-bye.